Okay, absolute value functions. Probably in Math 1, you guys you solved absolute value equations. Okay, now we're gonna show you how to graph them. Does anyone remember what absolute value? What do we know about absolute value? No one has any idea? Yes.
You said about absolute value.
Yes.
No matter what number it is, it's always positive.
Okay, absolute values, positive numbers. Okay, yes. Very, very good. Distance. Okay, we're done with the distance. I don't know why this will not. Let's see if it'll let me write. Nope, it's a little frozen right now. Okay, write that right there, distance away from 0, even though it won't let me right now. Okay, and it's not necessarily from 0, it can be a distance from any direction. Okay, so 5 away from 3 would be either 8, or 5 away the other way would be at -2. Nope, won't let me write here either. Very frustrating. Okay, do those 3 problems, the absolute value number 1, and sorry, just the 2 problems. Okay, so in the absolute value signs are kind of like grouping symbols. So you do the math in here first, then take the absolute value. So 5 minus 3 is the absolute value of 2. And what's the distance of 2? 2. Same thing with number 2. -6 plus 2, we do the math here. Very good, -4. And what's the distance of -4? 4. Okay. Any questions over that?
So whenever it's a negative function, there was a positive distance?
Yes, when I have a negative number inside the absolute values, it automatically changes to a positive, because now once we've done the math, it's how far away is -4 from 0? It's 4 away. Mm-hmm. Okay, so next one. We're going to graph absolute values and a linear equation. So the first one, we're just going to do with the function of f of x equals x, the parent function of a linear function. So we're just plugging it in, -2, f of x equals, so when x is -2, f of x is also -2. When x is -1, f of x is still -1. Let's graph those points. So -2, -2, -1, -1. If I plug in 0, what am I going to get? 0. If I plug in 1, what am I going to get? 1. And finally, when I plug in 2, I'm going to get 2. So this is my line. Okay, now we're going to use the same parent function, but with an absolute value. So now we're doing the parent function of an absolute value function. So here is our equation we're going to be using. G of x equals the absolute value of x. So when I have g of -2 equals the absolute value of -2. So g of -2. Class, what's the absolute value of -2? 2. Okay. And I keep doing that. I plug in -1. So g of -1 is equal to the absolute value of -1. What's the absolute value of -1? 1. Let's graph those points. So I'm going to go where x is -2 and y is 2. Graph where x is -1 and y is 1. Okay, what's the absolute value of 0, class? 0. Then we plug in 1. And what's the absolute value of 1, class? It's not -1. We don't change the sign. It's always positive. It's 1. Okay, and what's the absolute value of 2? 2. So this is my graph. So if you look at the linear function and the absolute value function, if you notice at 0 and greater numbers than 0 for x, they're the exact same numbers. It's the negatives for x that kind of reflect across the x-axis. So when it was -1 on the absolute value, it became +1. On the linear, it was at -2. Okay, when I was over here, it flipped to +2. Any questions over that? Okay, describe what the graph looks like. What do you notice about the above absolute value graph? What are the graph's characteristics? Okay, so you guys write out what you notice. Okay, Xavier, what did you notice? What's something you wrote? It's a V shape. Very good. There will always be a V shape. Anyone else get something different? Yeah?
It looks like it doesn't go past 0.
Okay, the parent function doesn't go past 0. Yes?
It reflects across the y-axis.
Okay, it has symmetry across the y-axis? Yeah. Not reflects. I mean, I guess you could call it reflecting. Anything else? Okay. So those are all good observations. Okay, absolute values are very similar to our quadratics that we've been doing all year. Okay. They have a vertex form. just like a quadratic had a vertex form that makes it easier to graph. It has the stretch, the shrink, the shift left, right, up, and down. Okay, just like a quadratic did. So if we remember, if it's a negative A, if A is negative, then it reflects across the x-axis. Your V will face down. So an absolute value is similar to a linear equation in the fact that it has a constant rate of change, unlike a parabola that had the patterned rate of change. It's going to rise at a constant rate of up 1 over 1, up 1 over 1. Not like the parabola that would go up 1 over 1, and then up 3 and over 1, then up 5 and over 1. The A value, though, does have the stretch and the shrink. If we have the absolute value of A is greater than 1, so if it's 2, 3, 4, then this is a vertical stretch. It's a vertical stretch. Yes.
For the plus sign, you just put that, right?
Yes, you don't need to put the plus, yeah, because it doesn't change. Okay, if the absolute value of A is in between 0 and 1, what numbers are in between 0 and 1?
0.5, 0.2.
Okay, fractions or decimals, right? If A is a fraction, then it is a vertical shrink. And remember, if I shrink vertically, that means my V is going to get wider. If I'm stretched vertically, that means my V is going to get narrower, skinnier. Does that make sense? Okay. Then the absolute value, the H value is the X value. It moves with the X. The absolute values are similar to our parentheses. So if it's inside those absolute values, the sign changes. So our negative H will move to the left. Not to the left, to the right. The opposite. Okay, inside those absolute values is the opposite of what we think. A positive H value then is going to move to the left. Any questions over that? Our K value is the Y value, so it shifts up and down. And it's just like we think. Positive K is going to move up, and a negative K will move down. Any questions over that? Okay, we're going to use this now to describe the transformations. So we're going to skip the graph for a second and just describe the transformations. So the 3 is the A value. The A value is greater than 1, so it is a stretch. The negative 2 is the X value. So it's going to move to the right 2. It's the opposite of what we think. And the 3 is the K value, which tells me about the Y. It's positive, so it moves up 3. Any questions over that? Okay, do the next one. Okay, Sam, what did you notice? Down one. The -1 is down one. One, what's something you noticed?
X plus.
Very good. It's negative, so it reflects across the x-axis. Blake, did you notice anything? Vertical shrink. It's a shrink. The A value is a fraction in between 0 and 1, so it's a vertical shrink. And the last one, Sasha, can you tell me what's the last one?
The left one.
So left 4. How are we doing? That's pretty easy. So in the homework, you'll have to do some of that as well. Okay, now let's review how to graph. Okay, graphing is going to be very similar to graphing a parabola. So it should be fairly easy for us. We've done this a lot. Okay, you first want to identify the vertex. Good. My vertex, again, change that sign. So it's a +3 and 2. Okay, the opposite values again are like the parentheses, so it's the opposite. It's a changing. So I'm going to graph where x is 3 and y is 2. Then we need to identify the A value. The A is the number that's going to be in front of the absolute value sign. Since there's nothing written in there, the A is 1. And the A value is similar to the slope. It's a constant rate of change. So I have to move up 1 into the right one, up 1 into the right one, up 1 to the right one. But I also have to do it on the left side, because after 3, all of those numbers are going to be flipped and become positive. So you have to go up 1, left 1, up 1, left 1, up 1, left 1. So it's 1/1, up 1, and then left and right 1, just like the parabola. You have to do it. It has the symmetry, so you have to move up and to the right and to the left. Okay, next one. We need our vertex. Okay. +2 and +4. So we're going to go where x is 2 and y is 4. And class, our A value? -2. So it's going to be down 2, but still right and left 1. So down 2, right 1, down 2, left 1. Down 2, right 1, down 2, left 1. Any questions over that? Yes.
So with absolute functions, is it usually just like symmetrical?
Yes, they will have symmetry through the vertex, just like a parabola did. Okay, on the back. Now, just like in our linear equations, I'm going to give you a graph and ask you to write the equation of it. So our formula for a vertex form would be f of x equals a times the absolute value of x minus h plus k. So we need to identify the vertex. Which is right here. So the vertex is 1 and 3. And then we need to identify the a value. From the vertex, how far up did I move and over? So it'd be 2 over 1, which is just 2. My graph is facing up, so I know it's a positive 2 and not a negative. Then you just plug it in. So you have f of x equaling 2 times the absolute value of x minus. Okay, remember this is your h value. And then plus the k value, which is 3. And that's my equation. Any questions over that? Okay, next one. Tarek, what is this, the vertex? 0 and 4, very good. Everyone find the slope or the a value. Lonnie, what's the slope? Close? -1. It's facing down, so it's negative. You're going down 1 and to the right 1, so -1. So then you just plug it in. Y equals negative times the absolute value of x minus 0 plus 4. When you simplify that, you can have it as just f of x, sorry, or y. I started with y. Let's stay with y. Y equals negative absolute value of x plus 4. So this is how you'll see it written on a standardized test. They probably would not put x minus 0. Any questions over that? Okay. Okay, now we're using an absolute value graph in relation to a real life scenario. So the following absolute value function represents Jill's run to a park and back home, where the deity represents her distance from the park of time. Write an absolute value equation to represent her run, then explain what the key features represent. So just like before, we would need to find, if we're going to write the equation, we need to find the vertex. Daniel, what's the vertex? 40, 0. Okay, the A value is tricky. Okay, I went up 1, but how far over did I go? 8, because I'm counting by 8s on the bottom. 1/8. So we plug that in. They're using D of t equals 1/8 times the absolute value of t minus 40. I could put a +0, but I don't really need it. So we can just leave it like that. Any questions over that? So that's the equation. Now we just need to see what all that means. In relation to Jill running to and from the park, what does the vertex tell me? 40, 0. What does that tell me about? What is the, what's this right here? Represent? Time. So what does the 40 represent? How long it took her to get there. Okay. The vertex is, it took her 40 minutes to get to the park. What about the A value? The 1/8.
I know it's going to decrease the time.
You ran 1
Yep.
kilometer.
Not just not the A value would be the whole distance to the park. Someone was saying it over here.
Ran a kilometer.
Yes, 1 kilometer in 8 minutes. It's the rate of change, how fast she's going. So A value is her speed. In this scenario, it's 1 kilometer in 8 minutes. Is that fast or slow? Or average? Is a kilometer more than a mile or less than a mile?
Less than a mile.
It's less than a mile. Okay, so if it like 1 mile in 8 minutes, okay, this is less than a mile. A kilometer is less than a mile in 8 minutes. Would that be? It's kind of slower, right? It's a little slower. Okay. Okay, what about the x-intercepts? We kind of already talked about it, right? Because the vertex is on the x-intercept, right? The x-intercepts represent when she gets to the park. Okay, what about the y-intercept?
It represents the distance to the park.
Okay. So in this case, where is she at when she starts?
5 miles away.
She's 5 miles away, and where is she starting from?
0.
Read it. Where is she starting from? Her house. So her house is 5 miles away from the park. Does that make sense? Okay, she lives 5 miles away from the park. Okay, also from the graph, you can tell that it took her the exact same amount of time to get back, right? Same time to get there, same time to get back. Because it ends at 80 minutes. Okay, so she's running very consistently at that speed. Okay, I want you guys to fill in this. List the changes that occur when you transform an absolute value function. Okay, and tell me what doesn't change.